Today we're going to talk about negative exponents. Okay? This is our topic. First, I'm going to show you what negative exponent means. So to do that, I'm going to kind of show you, see if you see the pattern. First of all, if you see x to the third power, okay? What does that mean, Samuel?
It's x times x.
Correct. It means multiply x 3 times. That's what the exponent tells you to do with that base, right? Now, let me see if you see the pattern. What if I go from this to x to the second power? What does it mean? Yes, x times x. Now, what if I write x to the first power? It means you just get x. Okay? Anybody see the pattern as to, as you decrease the exponent by 1, what is really going on as you go from x to the third, x to the second, x to the first? How about, one person see it? Okay, everybody discuss with the group, I'll give you the time. Go ahead. So how about, Aiden, what did your group come up with?
You divide by x.
Yeah, you're dividing by x. Isn't that what's going on? Right? What is x times x times x divided by x, class? X times xx, right? X times x. So if you divide each one by this x, that's what's happening to, thank you, that's what's happening to, right? As you're decreasing the exponent by 1, you're dividing by x. As you can see, that's what's happening from here to here, right? X times x, you had x squared. If you divide that by x, you get x, right? Now, what does it mean to divide by x? The same as using the definition of division is dividing by x is same as multiplying by the reciprocal of x, which is 1 over x, exactly right. So I'm going to represent it this way. Is that okay? Because you'll see why this will be a little bit easier for us to understand. Because dividing by x is same as multiplying by the reciprocal of x, which is 1 over x. So there you are. Oh, okay, before I get there, what do you think? I almost showed it to you. What do you think then x to 0 power will give you? Okay, I want you to all discuss with your group. Go ahead, think about it. What do you think? A lot of you are able to get this. The answer is 1, right? It turns out anything to the, thank you, anything to the 0 power is 1 except for 0 to the 0 power. That's undefined. Okay, you learn that later. And it will make sense actually as we do this because look, if you divide x, as you can see, I am decreasing the exponent by 1, right? As I go from x to the first to x to the 0 power, I'm dividing x by x. What's x over x?
1.
Right? Does that make sense? So therefore, as you can see, anything to the 0 power is going to be 1 because it's that base over that same base. Of course, can I divide by 0? Can x be 0? Can you have 1 over 0? Is that defined? It's undefined. Therefore, you cannot have 0 to the 0 power, right? Because you'll be dividing by 0. That wouldn't make any sense, correct? So, all the other numbers except 0, anything to the 0 power is always 1. Guess what a lot of people make a mistake in? They say something to the 0 power is 0. That's not correct. Right? Something to the 0 power is always going to be 1 except for 0. Now, but we haven't talked about any negative exponents, but look what happens as we move one down here, right? So as we go from, you see we had x to the third, x to the second, x to the 1, first, x to the 0 power. Guess what the next one is?
1 over x.
X to the negative 1 power. And so we have the answer. What does then this negative exponent really mean? When you have x to the negative 1 power, well, as we decrease the exponent by 1, we're dividing by x, right? Or multiplying by 1 over x. Who can tell me what x to the negative 1 power then really equals to? How about Libby? 1 over x is correct because what is 1 times 1 over x, guys? 1 over x. You see the pattern? What would, yeah, because look, to go from previous step to this, you're multiplying 1 times 1 over x. Isn't that what we get? Now, what would then x to the negative 2 will get you? Okay, everybody go ahead and discuss with your group. I'll wait. Okay, what do you think? All right, so a lot of you guys, I think, have the right answer. What did your team come up with? Kevin?
1 over x squared.
1 over x squared is correct. Because isn't this what's happening, guys? As you go, right, as you decrease the exponent, right, you are multiplying that by 1 over x. Previous step. So 1 over x times 1 over x, you get 1 over x to the second power. Can somebody guess what x to the negative 3 power will get you? How about Samuel Lee? 1 over x to the third is correct. What about if I have x to the negative 6 power? Carly? No, 1 over x to the 6. Are you all following? Does that negative exponent make the expression negative in any way? No, it doesn't. Please don't think that that exponent negative makes anything negative, right? That just makes it 1 over, right? That base. All right, so here's the key concept of the day. Let me see if you figure this out. Let me see, hold on. So here's the key concept of the day. X to the then negative n power. What would this equal to? Everybody go ahead and discuss with your team. Go ahead. What do you guys think? We just did a bunch of examples. What do you think? This is the key concept. N could be any numbers you want. X to the negative n power. What would that give you? Okay, go ahead. Everybody think about it. So, what did your team come up with? How about Aaron? What did your team come up with?
1 over x to the n power.
That's correct. It is 1 over x to the n power. How many people got this? Raise your hand. Very good. Does this make sense? Thank you. Does this make sense? Right? This is what we expected, right? It becomes 1 over x to the nth power. Again, does this negative exponent make this expression negative or at all or so forth? No, it does not, okay? It just makes it 1 over x to the nth power. Does that make sense? So today we're going to deal with many of these exponents and so forth. So let's review some of the rules that we learned already. Because turns out, you know those rules that we learned? We only had positive exponents, right? Guess what? When they become negative exponents, you think it'll still work? No, actually it works the same way. Okay, it works the same way. So before we get going, let's do a very simple one. What about then x to the negative 7 power? By the way, it says simplify. Isn't this already simplified?
No.
Why not? Why isn't this simplified? Who thinks they know why? How about Jason?
Well, I was just going to say because it's not.
Okay, so what do you think this becomes? Okay, first of all, x to the negative 7 power. It is 1 over x to the 7 power. And turns out, even though x to the negative 7 power looks very simple, when you are simplifying expression with exponents, turns out you cannot have negative exponent. Is that okay? So write this down. This is important. So when we simplify exponents, when we simplify, the exponent must be positive. If the exponent is negative, then you're not done simplifying. So please write this down. That's why it says simplify x to the negative 7 power. Even though it looks very simple, right? It's not fully simplified because the exponent has negative, right? We have negative exponents. Does that make sense? You understand what I'm trying to say, guys?
Yeah.
Can we have negative exponents when we're simplifying expressions? No. You must change it to positive. And we know how to do this, right? It becomes 1 over x to the 7th power, right? So write that down. So let's review some of those rules that we learned so far. We learned 5 rules for exponents, if you really think about it. And these, when we use these rules, we only had positive exponents. But as I said before, even if you have negative exponents, these rules still apply. It works the same way. Is that okay? So let's see whether we remember some of these rules. Who remembers what we do when we have x to the n power times x to the n? Okay, how about Brandon? Do you remember what we get when we have x to the n times x to the n? What do we do with the exponents? You add them is correct. So what do we get? X to the? That's correct. So we get x to the n plus n is what we get. Is that okay? You see how that works out? All right, so let's see if it works for negative exponents. So here's an example. We got 2 to the 3rd times 2 to the negative 5th power. By the way, for these rules, you have to have the same base, right, guys? If I have different base, you can't, right? Use this rule. So here we have same base, 2, 2, and then the first one, we have 2 to the 3rd times 2 to the negative 5th. What does then this become? How about units? 2 to the negative 2. Very good. You add them together, right? What is 3 plus negative 5, class? Negative 2. And can I leave it this way? No, I'm not done simplifying. We know what this becomes. 2 to the negative 2, class. How about Dana? What does that give us? 1/4 is correct. Okay, so there it is. Oops, let me show you. Okay, yeah, 1/4. Right, you get 1 over 2 to the 2nd. So, of course, 2 to the 2nd, the number is not that big, so you should multiply it out. If you get like 2 to the 10th, you don't have to multiply it out, okay? But 2 to the 2nd, you should know what that is. It's 4. All right, let's look at then next. Actually, 2 to the 10th is not that. It's not that bad. Like if you get 2 to the 100th, then you don't have to multiply. All right, so here, x to the m divided by x to the nth. who remembers what this tells us? How about, yes, Michael, do you remember?
Is it x to the m times 1 over x to the m?
No, this is just, you have the same base. Now, when you multiply these exponents with the same base, you add the exponents, right? With these powers. When you have the same powers with the same base, when you're dividing it, what do we do with the exponents? You remember, Michael? So for multiplication, we added these. For division, what do we do with these exponents? Yeah, we subtract them. Do you guys remember this?
Oh, yeah.
Okay, you could actually write it as a fraction, right? X to the m divided by x to the n is same as x to the m over x to the n, right? They have the same base. When it's written as a division or as a fraction, and they have the same base, you subtract the exponent. You guys remember that?
Yeah.
So again, this will still work for powers with negative exponents. So here, 6 to the negative third power divided by 6 to the 7th. Okay.
What if the base isn't the same?
If the base isn't the same, you can't use this rule. You gotta kind of work it out then. You gotta multiply things out and then simplify. But like for tonight's homework, most of these will have the same. So you get x to the negative third power divided by 6 to the 7th. 6 to the negative third power divided by 6 to the 7th power. What do we do with these exponents? How about Angel? So what do we get? 6 to the negative 4. Is it? Do we get negative 4? We really get 6. Okay, I could write this as, yeah. Is it 4? When you subtract, look. You have 6 to the negative third over 6 to the 7th. The same as this, right? So what do? You subtract these. Negative 3 minus 7. What does that give you? Negative 10. Be careful, guys. This is why I want you to be careful with these. It's very simple, but people, instead of getting the correct answer, they put like 6 to the 4th or 6 to the negative 4th. That's wrong. Negative 3 minus 7 gives you negative 10, does it not? Right? Be careful. Don't make that silly mistake. Okay, so of course we can't leave it this way. We cannot have a negative exponent. And so the answer is 1 over 6 to the 10th power. Okay? All right, are we good? So what about this third rule? If I have x to the m, the whole thing is now raised to the nth power. What do you do with the exponents in this case? How about, Claire, do you remember what we did?
Yeah. You multiply the m to the some h.
M. N. This is n. So,
X times x to the n power.
that's correct. You multiply the exponents, you get x to the mn power. All right? Okay, so let's see if it works for the negative exponent. So we have here 2 to the third to the negative second power. What would that get you? Eric?
2 and 3 times negative
Which is going to, you're right, 2 times 3 times negative 2, which is 2 to the negative 6, which is simply 1 over 2 to the 6. 2 to the 6 is not that bad. We know what that is. 2 times, you multiply that by, it's what? You're right. 64 because 2 to the third is what? 8. Isn't that right? So 8, and then you have 2 of those, you guys. You get 64. All right. Okay, and the next, this one's pretty straightforward. AB, you have now a product. The base whole thing, AB is being raised to m power. This means AB times AB times AB, and you have m of these. So what does this give you? How about Eugene? Do you remember? Yeah, you mean a to the m power and b to the m power, right? Okay, good. If you just say a and b m, that means you're multiplying everything, right? That'd be wrong. So you get a to the m times b to the m. That sounds like a and p m, doesn't it? Okay, then, okay, try this here. Now, what is your a in this case, class? 3. What is your b? X. Just right. If you have 3x, the whole thing raised to the negative 2 power. Again, the same rule applies for negative exponents. So what do we get here? How about Tajwar?
It's negative 9.
Okay, don't give me the answer yet. So what do we get? We get 3 to the what power?
3 to the
Negative second times x to the?
negative 7.
Good. That's what we get. And of course, they're separate like this, right? You could do that. And then, of course, 3 to the negative 2, Tajwar is right, is 1/9, right? Because you get, isn't this 1 over 3 to the second? And what about x to the negative 2? That is 1 over x to the second. And of course, you don't want to leave it this way. So simply 1 over 9 x squared, right? Okay, so there it is. Very straightforward. As you can see, all these rules, we got one more. All these rule applies for negative exponents as well, right? Not right. It doesn't have to just work. It does not. It works for both negative and positive exponents. Okay. Let's look at the last rule. And this one's very similar to the one that we just did. Now instead of as a product, we have it as a division, a over b, right? A over b, whole thing to the n power. What do you get when you have this, Royce?
A to the n
Over b? No, this means a over b times a over b times a over b, m of these. So what does it become? A to the m over b to the m. You have, right? And b is also on the denominator, right? So again, this works for negative exponents as well. So here's the example. 3 over 5 to the negative second power. So Samara, what do we get here when we have 3 over 5 whole thing to the negative second power? Do you get negative 9 over negative 25?
No.
It's not that you multiply 3 times negative 2 and 5 times negative 2 or something. Or, you know what I mean? It doesn't become negative at all. It just becomes 3 to the what power? Follow the shortcut here. 3 to the... Look at the shortcut. 3 to the negative 2 power, isn't that right? Over what? 5 to the negative 2. Does that give you negative 9 on the numerator? Is that what it means? 3 to the negative 2? No. Samara, what does 3 to the negative power mean? Look at the key concept. Look at the very beginning. What did we say? Something to the negative power means what? What do we say? X to the negative n power gives you what, Samara? Look at the very beginning of your notes. X to the negative n power. What does that give you? Yeah, 1 over x again. Now, what does then 3 over, just don't worry about the one on the bottom. Just look at this. What does 3 over negative 2 power give you? 1 over 3 to the second. Correct. What does then this give you? 5 to the negative 2. That's right. Do you understand? It doesn't make anything negative or anything like that, okay? So please be careful. So, we basically get this. Yeah, can we leave it like this? Okay, we can simplify a little bit. Okay, we know what 3 to the second power is. Hold on. Okay. So can I write it this way? Right? Because we know that 3 to the second power is 9. 5 to the second power is 25, right? Am I done here? No. For fractions, you cannot leave your denominator or the numerator as a fraction or decimals. That would not be good, right? So then, what does this really mean?
1 over.
Okay, hold on.
Sorry.
What does this really mean?
Oh, I see.
How about, yes, Brianna? Yes, because the fraction bar, right, it's really a grouping symbol. You guys remember that? So this whole thing, yeah, it means division. You divide the numerator by the denominator. So, yeah, this just simply means 1 over 9 divided by 1 over 25. Isn't that right, guys? No? Okay, clear. Something over something, right?
Yeah.
The fraction means the numerator divided by the denominator. Isn't that what it means? So my numerator happens to be a fraction. So it's 1/9 divided by the denominator, 1 over 25. That's what it means.
Right.
I'm not done here.
No.
And then what do? What does division really mean? Multiply by the? So guess what? This means 1/9. I know, that's why. I'm not done.
Oh.
So 1 over 9, what? Times what?
25.
25 over 1, right?
I
Reciprocal.
thought you said you were done.
Oh no, I
was
wasn't done, sorry.
No.
Yeah, so now we're done here. Now we're done because now we get 25 over 9. How many people got 25 over 9 as the answer? Does this make sense?
Yeah.
Okay. All right. Good. So that's really good. So a lot of you were able to see the shortcut. If I have A over B, the whole thing to the negative 1 power, it just means B over A. Well, to the 1 power, right? To the first power. If you want, let's just B over A, right? That's really because it's 1 over A over B, isn't that right? Right? Because something to the negative 1 power is 1 over A over B. What's this? 1 divided by A over B, which is the same as what? 1 times, I said 1 times B over A, right? That's how you get this. This is the reason, but That's the shortcut. A lot of you saw that. So if you saw this, what about this? A over b to the negative n power. Anybody want to guess what this y give you? Two people see it? Right, so a lot of you saw the shortcut. If the fraction is to the negative power, you just have to flip it. Yeah, flip it, right to the reciprocal of it, and then it becomes positive. So what about a over b to the negative n power? Matthew? Exactly. You get b over a to the n power, which is b to the n over a to the n. Because turns out you could actually think of this as this. Watch this. See if you can follow. A over b to the, instead of negative n power, this is the same as negative 1 to what power? N power. Isn't that right? Because what's negative 1 times n? What's negative n times n? Negative n. So look, doesn't this become, we just said a over b to the negative 1 is what? B over a, right? And that becomes to the n power, and you get the same thing. So that's kind of nice to know. It's kind of nice to know this shortcut, right? So there's a reason why behind it. Okay. Now we're finally ready to do some examples. Okay, because now that we've reviewed all these, we're ready to do some examples. Okay, here we go. All right, take a look at example 1. I got 4 times 3 in parentheses to the negative second power. Now, do we still have to follow the order of operation?
Yes.
Okay, so what do we need to do first? How about, let me call somebody random. How about Eugene? Yeah, you multiply what's inside the parentheses first. What is 4 times 3, class?
7.
Is 4 times 3 6? 4 times 3 7? So we get 12 to the negative 12 power. Hello. We get 12 to the negative 2 power. Okay. So then, of course, it is 1 over 12 to the second. You get 1 over 144. Easy enough? Now, if you got this, take a look at this one. I gave you B. Now, it's the same exact one, 4 times 3 to the negative 2, but there's no parentheses around it. Do you think we're going to get a different answer on this?
Yes.
Do we still have to follow the order of operation?
Yes.
Everybody go ahead and try. I'll wait for you. So how many people noticed that, wait a minute, I have to deal with the exponents first, right? That's what the order of operation says. How many people did this first? 4 times 1 over 3 to the second? Yes? Because you got to deal with 3 to the negative second first, right? The exponent. What is 1 over 3 to the second, class? 1 over 9. So 4 is really 4 over 1. How many people got 4 over 9 as the answer?
Oh.
Easy enough? Do you see how even though A and B, even though they look very similar, because one of them had the parentheses, the other didn't, do you see how it changes the answer? Very good. Let's look at a couple other ones. Here we go. So let's look at C. It says 3 to the negative 1 power plus 3 to the second. Now, this one, I put a star. I don't know if you can see that. It's up there. The reason I put a star is because people try to add these exponents inside. Whoops. And you don't, let me move it down because you don't see the whole front. Hold on. Okay, sorry, it was sort of hidden. Okay, there you go. 3 to the negative 1 power plus 3 to the second to the negative 1 power. Now, can I add these exponents right now?
No.
Why not? Because it looks so, they have the same base. Why not? Camilla? Because it's addition. When do you add the exponents? When you're multiplying these and they have the same base, right? Well, this time they do have the same base, but it's addition. So guess what? You have to now rewrite these as a fraction first. Is that okay? So what is 3 to the negative 1, guys? 1 over 3. What is 3 to the second? 9. The whole thing is raised to the negative 1. So you basically get 1/3 plus 9 over 1 to the negative 1 power. We still have to follow the order of operation, don't we? So we have to deal with what's inside the parentheses. How do we add these fractions? What do you need to add fractions? Common denominator. Yeah. So what is the common denominator in this case? 3. So how do I make 9 over 1 to have a denominator of 3? Multiply by 3 over, not both sides, this is an expression. 3 over 3, multiply top and bottom of 3. Okay, so you get 27 over 3. So when you add this together, you get what? 28 over 3 to the negative 1 power, right? Am I done?
No.
You may not leave as negative exponents. Who can tell me the answer? How about Dakota? 3 over 28 is correct. Remember that negative 1, it just gives you that reciprocal of it, right? Because it really becomes 1 over 28 over 3, doesn't it? So it just sort of flips it. All right, try this yourself. They look very similar. Now, this time I made it into a what? Instead of addition, I now have Multiplication, you should now be able to do this without any problem. Look at the difference though. Go ahead, everybody finish. In this case, can we add the exponents now?
Yes.
Yes, we can because it's multiplication. Joseph, what do we get inside the parentheses? Inside the parentheses? Don't do everything yet. Just what is 3 to the first negative 1 times 3 to the second? 3 to the first power. And of course, this whole thing becomes 3 to the 1 to the negative 1 power. So you're right, it's 1/3. Right? How many forgot 1/3 as the answer? Easy enough? Yeah. Very good. Let's look at some of the other examples and we'll be done. Okay. So example 2 says this. Y to the 5th times y to the 0 power all over y to the negative 2, the whole thing to the negative 3 power. So you got y to the 5th times y to the 0 power over y to the negative 2 power, the whole thing raised to negative 3. By the way, what's y to the 0 power, class?
What?
Okay, so can I just write it this way?
No.
Like as soon no?
No.
I'm just going to replace y to the 0.
Don't you add 5 and 0? What?
Yeah,
Oh,
you could add 5 and 0, you still get y to the 5.
Right.
So it's the same thing. Yeah, you could do that. Yeah, you get y to the 5th no matter how you do it, right? You could either change this to 1 or, yeah, add 5 and 0, you get 5. Now, we basically have this, right? Y to the 5th over y to the negative 2. What do we do, guys? What do we do the exponents? One person's here? Okay, how about Chuck? You can't, but then remember we know the shortcut. If you have y to the 5th over y to the negative 2, what do we do with the exponents? No. You don't flip it. Don't worry about this. Remember, you gotta follow the order of operation. Okay. So remember the rule when you're dividing these exponents and these powers with the same base. What do we do with the exponents? When you're dividing them, you do what? Look at your notes. You subtract them. Did you all do that? So don't we subtract these? Now be careful when you subtract, you get y to the 5, not y to the 5th minus negative 2. What does that give you, class? Y to the 7th. Okay?
How did you get that?
Okay, give me a sec. Okay, let me finish. Carolyn, we get 5 minus negative 2. What's 5 minus negative 2? Because you get y to the 5th over y to the negative 2. You just subtract the exponents.
Oh, okay, yeah.
So how many people got y to the negative 21? Which is 1 over y to the 21st. Easy enough? Have a great day, guys.